Bonjour, Algebra 2 kids. So we're doing section 4.10, write quadratic functions and models. All we're doing today is typing points and tables into our graphing calculator and then writing quadratic equations. This is very similar to what we did with linear functions not too long ago. This is called regression, and that's where you fit points to a line. This time though, we're going to fit points to a U-shaped line instead of a straight line. So linear regression is fitting points to a straight line. Here we're fitting points to a U-shaped line. So what we do is we get out our graphing calculator. If you need to pause the video at any time, please do that. But you're going to get out your graphing calculator. We're going to go to Stat. We're going to go to Edit. We're going to clear our lists. We should know how to do this already. If you don't, you are up, you highlight L1, hit clear, and then enter. Then we go back to our problems and we type in our x values into L1, -1, 0, 2. And then we go to our y values in our problem and we type those into L2. I don't remember what they are. Oh gosh. This is just... There we go. Okay, now we're good. I think that's what they were. Yep, that's what they were. Okay. Whew! Bad memory today. So, we go to stats. We want to calculate. This time, what are the names of these U-shaped graphs? Parabolas, or, well, no, the other name for them. It's listed on the screen. Quadratic equations. So we're going to do number 5 here, quadratic regression, because again, we're fitting these points to a U-shaped graph. What we did before was number 4. That's linear regression. Today we're doing number 5. So you can just hit number 5 and then hit enter. Boom. There's our quadratic equation. There's our A, B, and our C. So we write that down. 2, 1, -4. So our answer is y equals 2x squared minus x plus 4, and that's it. That's all we're doing. Is that easy? Yeah. Okay, the crowd goes wild. Okay, next one. We're given x-intercepts and a point this time, but x-intercepts as points are just... Oh, I did that backwards. Are just the x value and a 0 at the y. So really, our 3 points look like this. So when it says x-intercepts, it just means put 0 as your y. So we're going to go in here. We're going to go to stat. We're going to go to edit. And then we're going to change these so they fit. And I already forgot what they were. 2, 5, 4. We go over to our y's. We can change those. 0, 0, -2. Again, stat, calc, number 5. Boom. 1, -7, and 10. So again, here's our answer. Yay! Yay! Okay, so that's our equation for this one. I'll do one more super quick, just so this one's one from a graph, but it's the exact same process. Oh, I can't even remember. -3, -6, -4. Stat. Edit. Oops. Oh, I did that right. -3. -6. -4. And then I have to remember the other ones. 4, -2, -2. Oh, dang. Is that right? Yeah, okay. I can't remember. Okay. Actually, here's a shortcut. Hit second quit. Go to this screen. The blinking, the blinking cursor up there. Hit second enter. Because that just spits out what you just put in. And then, there you go. 224. Oh, big numbers. 220, 46. 2x squared, 20x, 46. Easy peasy. Lemon squeezy. Last thing, example 4, solve a multi-step problem. Here we're talking about pumpkin tossing. So what we want to do is we want to write an equation. We want to write an equation of the quadratic model for this data. So here, let's just see what pumpkin tossing is. So I'll show you a video of that. Right here, right here, right here, right here, and right there. There we go. Oh, here it goes. 3, 2, 1. Whoa! Oh, that went flying. That went over 1,000 feet. That's crazy. Go trebuchets. That's exciting. The crowd just went wild there. That was really exciting. Anyway, here we go. So that's what pumpkin tossing looks like. And then we're going to use our table here to oh, that's small, but it'll work. There. Okay. So we're going to enter in our stat, edit, and then we're going to type in our angle degrees as our x values. This is the really exciting part of this video, watching me type in the numbers, but whatever. And then we're going to type in the distance they traveled. 372, 462. Okay, there we go. So we got all of our data enter in. What are we going to do? What are we going to do? We're not going to dance. We're going to hit stat. We're going to go to calc. And then we're going to go to quad regression. The crowd is kind of weird today. Hey, there it is. Wow, look at all those decimals. Anyway, but you know, you just round to the hundredths, I'd say. All the science people are probably like, wait a second. Anyway, sig figs and all that jazz. So what this equation does is if I said, oh, I built a catapult that launches at an angle, so the launch angle is this angle right here. That launches at an angle of, whatever, I don't know, 35 degrees. I could put 35 in for x, and then it would give me the distance, approximately, that the pumpkin would travel. So that's pretty cool. So any kind of flight things is where we use quadratic slots. That's what a lot of the problems we're doing today will be about. Anyway, there you go. There's a video. Thanks.